Okay guys, welcome back again to another video. So in this video we're going to talk about the decarboxylation with PLP. So here we are going to talk about the alpha amino acids, how these alpha amino acids can process with decarboxylation. So this is basically the reaction, right? We are using PLP and enzymes to remove this carboxyl part, so we can obtain a amine like this. So let's talk about the mechanism. This is not a much complicated mechanism, but there are some few points which you need to be focused on. So let's dive into the mechanism. Okay, first we have two molecules. So let me take another color. Okay, white color would we do? Okay, that's good. Right. So here we have our alpha amino acid and here we have our PLP. This is the PLP. Now, when the reaction occurs, the first one is the imine formation. Imine formation. I haven't drawn the mechanism for the imine formation because there are some few steps in imine formation which are very fundamental organic chemistry. I hope you know it. If you are not recalling it, like if you have no idea about it, it's completely fine. I will put the link here. Just follow up that video. It's very short video, I think about 3 to 4 minutes, I guess. So imine formation is very important in the organic chemistry and in the biosynthesis pathways. The first step would be the imine formation. Basically what happens is, you know, there's a carbonyl group here, right? Carbon and double bonded oxygen. This double bonded oxygen is replaced with this nitrogen. You can see here. This is what happens. So here there is a carboxyl group. I have drawn it spread outly. Yeah, I have drawn it a little bit spread outly. Okay, in the next step what happens is, so let me draw these things. Okay, in next steps what happens is, you can see here this OH2, this bond between the hydrogen and oxygen is going to be broken. Due to this bond will be here. It will go and form a pi bond between the carbon and nitrogen. Now you can see this nitrogen is getting unstable, so it's going to push this double bond towards this carbon and this carbon. Now our ring getting unstabilized, so the shifting can be happen. This double bond is shifting to here and this double bond is shifting to a proton. Now we will have our structure like this. Okay, this is the structure. So you can see, as I have mentioned in our transamination video, with this reaction proceed, our ring's aromaticity getting disturbed, which makes this structure relatively more unstable. So what happens in the next step is, this ring is gonna retain its aromaticity and get that stabilized. So this bond will be broken and a double bond will be formed between the nitrogen and this carbon. Now this carbon getting unstabilized, so it will shift this pi bond to this specific location. Now you can see this carbon is getting destabilized, so it will go and attack to a proton. Now we will have our structure. Let me go to the next slide. Here. Oh, sorry. Yeah, I just confused you. Sorry about this. This is not gonna happen, right? Not here. This bond will move into here, and here from this one it will go and attack to a proton. I'm very sorry about this. I just confused with the transamination. Okay, so here you can see this double bond is shifted to this place. There's a carbon here, so double bond will be formed between this carbon and nitrogen. Now because of this bond shifted to here, this nitrogen getting destabilized. Because of that, this nitrogen and carbon's pi bond will go and attack to a proton in the environment. So now we have a structure like this. This is our structure. You can see there's double bond between this carbon and nitrogen. There is no double bond here, which because it has attacked to a proton now attached to this carbon. I hope you clear with that. I'm very sorry about the confusing right here. Okay. Now in the next step we have our hydrolysis of imine to form a line. From this hydrolysis, aldehyde product will be formed. Here we have the aldehyde product and our amine product. So this is our amine. So now you can see our initial molecule was this one. We had NH2 group and we had carboxyl group. With the reaction, what happened is, you can see there's only difference between the product and our initial molecule is the removal of this carboxyl group. There's no carboxyl group here. This is basically the decarboxylation with PLP respect to the alpha amino acids. I hope you get the idea. These are pretty much important mechanisms. There are not too much. Just write the mechanism 3 to 4 times, then you will get the idea and you will be able to memorize it. So I hope you got something in this specific video. So if you have any questions, feel free to comment below, and also if I have made some mistake, feel free to mention it in the comment section. Thank you.